Hi, I'm Kevin, and what I'm really excited about in the new version of Flutter are the new integration testing capabilities and the faster iOS release builds. So today I'm going to talk about how you can get faster iOS release builds, and I'm going to show you how to set up the integration test package to run your tests on simulators, real devices, and how to run those tests on a device farm. So a bit about myself. I work for Codemagic and I help people set up CI/CD pipelines. And some of the most frequent questions I get are, how can I make my builds faster? And how can I run my integration tests on real devices? So I can't tell you how excited I am about these new improvements in Flutter. So let's jump into it and start by looking at some slides about iOS release builds, and then we'll look at how to set up the integration tests. If you want to run your iOS app on a physical device or publish it to the App Store, you'll need to archive your workspace and then export it as an IPA. In Flutter, we've got the Flutter build iOS command, which prepares the iOS codebase, but this only produces a .app bundle. In order to get the IPA, we have to archive the workspace either by using the Xcode GUI or by using the Xcode CLI tools to run commands such as Xcode build archive and then Xcode build with the export archive flag to produce the .ipa file. So essentially you end up building the app twice, once when you prepare the code base and get your .app, and then again to obtain the IPA. And one thing to note is that when you create the archive from the Xcode workspace, it builds the entire app again from source, because when archiving, no derived data or cache will be used. And this is one of the reasons why building an iOS app for release takes significantly longer than building an Android app. The good news is that with Flutter version 1.24.0-6.0 and later, the command flutter build IPA can be used, and it's highly likely that by the time you see this talk it will be in the stable channel already. This command reduces the time it takes to build your iOS release builds, because it does not build the .app file and creates the archive, which then just needs to be exported as a .ipa. This is a super simple way to speed up your release builds. Let's run it and see how simple it is. So I've opened up VS Code and opened up a Flutter application. I'm now going to go into the terminal, and then I'm going to run the flutter build IPA command. So what you can see is that it's created the XC archive, and from this we can export the IPA file. I was curious to find out how much faster the builds are, so I ran quite a few tests, and here are some of the results I got. So for a simple Hello World app, I saw a 12% reduction in build time on average. And with more complex apps, which contain more dependencies and generally have longer compilation time than a simple app, I saw an average reduction of about 33%. Obviously, the preparation of the iOS code base is a more significant part for smaller apps than it is for bigger apps. So it looks like we're getting great savings in the compilation time with using Flutter build IPA. So let's take a look at the new integration test package. Integration tests allow you to test the UI flow of your app or a large portion of it. Before the integration test package was introduced, you had to use Flutter driver, and running integration tests with it was quite flaky, unreliable, and it wasn't able to adopt new features. And also it wasn't so straightforward to write the tests themselves. But fortunately, the Google teams introduced the integration test package, which makes it easier to write the integration tests as it uses the same syntax as widget tests. This package also makes it possible to run our tests on real devices in a standard way, similar to how you would run native Android tests with Espresso. Basically, two binaries are created. One is a debug version of your app, and another is a version that runs the test on that app. This means that you can run your tests on real devices and use services such as Firebase Test Lab or AWS Device Farm. I've created a simple application to test the integration test package. So let's have a quick look at the app so you can understand what it does. So here we've got the Feel Good app. It's a very simple app that lets you put in your name, and it will then show you a message that should hopefully make you feel good. So it's got some basic validation. So if you try to press the Feel Good button down at the bottom right here, it's going to show you a validation message saying you should input some text. And then when you type in your name, it should give you a greeting and say, "Hey Kevin, you're looking sharp today, it's going to be a great day. And there you can click the close button. Now, for our tests, we want to run through this UI and check to see if our validation message appears and whether our alert dialog appears. But before we can do that, we need to add some things to the actual project. So let's start by doing that. Now, all the things I'm going to be showing you, I've created a project and put it up onto our GitHub page. So have a look down in the description. And if you can't follow along with everything I'm showing you now, then head over to our example project and go through the README, and you should be able to see what's been done here. Okay, so the first thing that you're going to need to do is add the integration test package to your project. So first of all, head on over to pub.dev and then search in the packages for integration test. And then you should find this package, integration_test. And then you can copy the latest version that's available by clicking here. And then what you'll need to do is head on to your pubspec.yaml file. And then you can see that I've already pasted this in under my dev dependencies for my project. The next thing you're going to have to do is create a folder called test_driver here in the root of your project. And within that folder, create a new file called integration_driver.dart. And in there, you need to have these statements that import the integration test driver and has this main method. After that's been created, you need to create another folder called integration_test. And within there, create a file called app_test.dart. And this is where we're going to be writing our integration tests. So in this file, you'll notice we've got a main method, and the first thing that's required is that we have this integration test widgets flutter binding.ensure initialized before we can actually run our tests or write any tests. So to start writing our first test, we'll use test widgets, which expects a description. And in this case, we're just going to write no input in name field displays error validation text. And then we need to provide a callback, and we're going to say widget tester and give this a name of tester. And this expects us to use an asynchronous function, so we'll write the async keyword there. Now the first step is to provide the root widget in your application, which in my case will be provided using pump widget and then the name of the root widget, which is my app. And after we've done that, we can start interacting with the UI. So the first thing that I want to try to do is find the floating action button and then tap it. And to do that, we're going to use await tester and then tap, and we're going to find it by using find by type, and we'll write the type of widget we're looking for, which is a floating action button. Okay. Then, after we've done that, we need to just allow the animation to settle correctly. So we're going to use pump and settle, which will make sure that there's no active animation still occurring on the screen before we try to do anything else. Then we'll write our expectations. So an expectation consists of a finder and a matcher. So if we write expect and do a find by type, and we're going to put in here what we're looking for. So this is my home page, which is the home page widget, and we're going to say that this should find one widget, and finds one widget will go in there. And then we're going to expect that the validation text appears beneath the text input field there. So let's write expect find text, and then we're going to enter the string that we expect to appear on the screen there. So input some text with an exclamation mark, and we'll use finds one widget And that should be our first test ready to use. Now we're going to just extend this a bit with some with another test that I've already prepared. So to give this a little bit more to do. Again, this uses the test widgets function with our description and the callback function here. It uses the pump widget to pass in the root widget, and then we're going to enter some text here by searching for the text field by its key, which I've already added as text field, and then provide this input text string containing Kevin. And then we're going to again tap on the floating action button. We're going to wait for any animation to complete, and then we're going to expect to find the text "Hey Kevin" on the screen. And just to put in some artificial delay, I've put a sleep command here to leave that alert on the screen for 5 seconds before tapping on the text button that was on there that says close, and then that should complete the test. So let's give this a try. So to see what your tests look like, you've got two options really. If you're in VS Code, then you should be able to just click on the run button here, which will run the test, or if you prefer to run it from the command line, then you would enter flutter drive -- driver and then point it to the location of your integration driver.dart file, and then add this target and point it to your app_test.dart file. I'm just going to click the run button here, and you'll see that it's going to go through a few actions, which will mean it's going to recompile the app, rebuild it before it runs the test. So it would be good to have a look at the output in the debug console, see what's happening here. And this is where we'll see the results of the test as well. Okay, so it's launching the test application. Okay, so you can see in the output log here that it ran the first test, which was no input in name field displays error validation text. And the next test was run that text is entered into field and alert is shown including name entered. So it's giving us all tests passed in this case. So what would happen if your test failed? Well, let's just make a change to the test that we've written, and then we should be able to just rerun this test, and we'll see that it's launching again. Okay, and this time you can see that one of our tests has actually failed, and we can see which one it was and what the problem was. And we get a message down at the bottom here saying that some tests failed. So this is great for catching issues in your UI as well. So I'm just going to change this value back to the correct value, so we can then proceed to the next step of preparing this to run on an Android app, and then run it in a Firebase Test Lab device farm test. So now we've seen how to actually write our integration tests and run those locally on a simulator. The next step would be to try running this on a device farm and configure our Android project, for example, correctly so we can do this. So there's a couple of steps that you need to do, and they are as follows. So firstly, if you expand your Android project folder and then go to the app folder and source, you'll need to create this folder here called Android Test with a capital T. And it's important to note that in this folder you have a Java folder and then you need to create a folder structure which matches your package name. Now the package name for my app happens to be io.codemagic.integration, and I've created individual folders for each parts of that package name. Then within the integration folder, you need to create this main activity test.java file, and within there you have to add this file content, which you'll need to update and specify your package name here, and also add it here. Now, as I previously mentioned, you can get this from our GitHub repo example and just copy paste it into your project. And likewise, you'll have to expand this main folder here, Kotlin, and then add the same folder structure as you did here, but without Java. And then if you don't have this file already, this main activity.kt, then you'll need to create it and then add the following content and then put in your specific package name here. And finally, you'll have to open up the build.gradle file, and this is specifically the one in the app folder, and go down to the dependencies section and add the following 3 lines to that section. And just to reiterate once again, you should look at the documentation for the integration test package, and you should be able to just copy paste these values from their documentation into this file. So now we've prepared the Android project, we should now be able to start thinking about running these integration tests on Firebase Test Lab. I'm not going to go into the steps of configuring Firebase Test Labs in this talk, but the essential things that you need to do would be to create a Firebase project, then create a service account that you can use to authenticate from either your local machine using the gcloud SDK or from a CI/CD service. And you'll also need to enable the Cloud Tools Results API. I'll put a link to the Firebase Test Lab documentation in the description of this video for further information. We're now ready to start building our APK files so we can upload them to Firebase Test Lab and run our instrumentation tests. So to do this, I've created a script to run the commands that are required. And I've also installed the gcloud SDK locally on my machine, so I'll be able to do the upload. So if we look in this file here, this test_firebase.sh file that I've created, and again, if you want an example, then head over to our GitHub page, which is linked to in the description, and you'll be able to use this yourself. You'll also find in the root of that repository a file called codemagic.yaml, which shows you how to run these commands as part of a CI/CD pipeline. Now, the first thing that it does is run the Flutter packages pub get command to make sure we've got all the required dependencies for our project. I've defined some variables here, the first one being the name of the Firebase project that we're working with, and then also another one that will be referencing the path to my Google Cloud key file JSON file that I'm going to use for authenticating with Firebase. We're then going to go up one directory and then just delete the build folder if it exists there already. And then the next thing we're going to do is run the Flutter build APK command to prepare the Android code base. I'm also going to require the path to the instrumentation test that we wrote, which exists in app_test.dart. So in this case, I'm just going to use the present working directory and then pass in the rest of the path and store it in this variable here. Next, we're going to just change into the Android directory and then run the gradle w command to assemble the Android test APK. Then we're going to run the command to assemble our debug APK and passing in the instrumentation tests path that we've defined earlier. And then finally, we're going to use the gcloud SDK and authenticate using our JSON file. And then we're going to set the project to the project that we want to work with. And then finally, we're going to run the test on our Android devices and say it's a instrumentation test. We're going to upload the appdebug.apk and also upload the Android test APK, and we're going to specify a timeout of 3 minutes. So let's just open up the terminal to run this, and if we just first change into the scripts folder, and then we should be able to just run this test Firebase script that I've written and just observe what happens. So first it's going to assemble the debug APK. Okay, so we've had both APKs built successfully, and now that we can see that it's uploading first the app debug to Firebase Test Lab, and now the test is pending, and now the tests are running. Okay, so the instrumentation testing is complete. All of our integration tests ran, and we can see down here at the bottom that the outcome was passed and that our 2 test cases passed. The other thing that you can do is actually click on this link here, and that will open up Test Lab, and then we can click on the link for our test results. We can then go and look at the test cases, and this will show us that we had 0 failed, 2 passed, the description of the test that was run. We can look into the logs, and also we can look at any videos that were produced. So if your tests run for longer than half a second, then a video will be created that you can look at. So let's watch this one. So typically the tests run very quickly, and that's why I added some artificial delay in the process there so we could get a video produced. Otherwise it may not have even taken half a second to run the test. Hopefully you found this useful, and as I said, if you look at our GitHub page for the demonstration app and the scripts, hopefully this will help you get started. So that brings us to the end of the talk, and I hope you're as excited as I am about these new features, and that you'll be taking advantage of these faster iOS release builds, and you'll now be able to set up your own integration tests. Thanks again for taking the time to watch, and goodbye.